Monitoring is the act of collecting and analyzing data to determine the performance, health, and availability of your business applications. An effective monitoring strategy helps you understand the detailed operation of the components of your application. It also helps you increase your uptime by proactively notifying you of critical issues so that you can resolve them before they become problems. Azure includes multiple services that individually perform a specific role or task in the monitoring space. Together, these services deliver a comprehensive solution for collecting, analyzing, and acting on the telemetry of your application and the Azure resources that support them. They can also work to monitor critical on-premise resources to provide an hybrid monitoring environment. Understanding the tools and data that are available is the first step in developing a complete monitoring strategy for your application. The diagram here gives us a high-level view of Azure Monitor. At the center of the diagram are the data stores for metrics and logs, which are two fundamental types of data used by Azure Monitor. On the left are the sources of monitoring data that populate these data stores. On the right are the different functions that Azure Monitor performs with this collected data, such as analysis, alerting, and streaming to the external systems. In the next set of videos, we'll take a look at different monitoring services that Azure provides and their key capabilities. Azure Monitor provides three main capabilities: monitor and visualize metrics, query and analyze logs, and finally, set up alerts and actions. These three capabilities makes Azure a powerful solution for not just cloud-based resources, but also for on-premise applications. The first point, which is monitor and visualize metrics. The numerical values that are available from Azure resources will help you understand the health, operation, and performance of your system. Logs are activity logs, diagnostic logs, and telemetry from monitoring solutions. So the analytics queries will help with troubleshooting and visualizations. Alerts notify you of critical conditions and potentially take automated corrective actions based on triggers from metrics or logs. All data collected by Azure Monitor fits into one of the two fundamental types, metrics and logs. Metrics are numerical values that describe some aspect of a system at a particular point in time. They are lightweight and capable of supporting near real-time scenarios. Logs contains different kinds of data organized into records with different sets of properties for each type. Telemetry such as events and traces are stored as logs in addition to performance data so that it can all be combined for analysis. For many Azure resources, the data collected by Azure Monitor is displayed on the overview page in the Azure portal. For example, virtual machines have several charts displaying performance metrics. You can click on any of the graphs to open the data in the Metric Explorer in Azure portal. That will then allow you to chart the values of multiple metrics over time. You can view the charts interactively or pin them to the dashboard to view them with other visualizations. The log data collected by Microsoft Azure is stored into a service offering called as Log Analytics. But can you imagine the amount of data that will be collected from virtual machines, databases, storage? And yes, Log Analytics stores everything. But how do you query, retrieve, consolidate such information? Well, you can run certain query language which Microsoft calls as Custo, and you can run that rich query language to quickly retrieve, consolidate, and analyze the collected data. You can create sample queries using the Log Analytics page in Azure portal, and then either directly analyze the data using those tools or save the queries for visualization or getting alerts based on the rules. Azure Monitor uses a version of this query language. Now, this is suitable for simple log queries and also includes advanced functionalities such as aggregations, joins, and smart analytics. You can quickly learn the query language using multiple lessons Particular guidance is provided to users who are already familiar with SQL and Splunk. Azure Monitor can collect data from a variety of sources like applications, operating systems, and any other services that rely on it. Azure Monitor collects data from each of the following tiers. It collects information from application monitoring data, which has the data about the performance and functionality of the code you have written, regardless of its platform. Guest OS monitoring data. Data about the operating system on which your application is running. That could be running in Azure or in a different cloud or probably on premise. Azure resource monitoring data. That is the data about the operations of an Azure resource. How about subscription monitoring? This is the data about the operation and management of an Azure subscription, as well as the data about the health and operation of Azure itself. Azure tenant monitoring data is also done where you get the information about the operation of tenant level Azure services such as Azure Active Directory. As soon as you create an Azure subscription and start adding resources such as virtual machines and web applications, Azure Monitor starts doing its work. It starts to collect data. Activity logs will then record when resources are created or modified. Metrics will tell you how the resource is performing and the resources that it is consuming. So it starts to collect various telemetry information for the internal operation of the resource and allows you to configure different data sources to collect logs and metrics from Windows and Linux guest operating systems as well. Azure Advisor is a personalized cloud consultant that helps you follow best practices to optimize your Azure deployments. It analyzes your resource configuration and usage telemetry. It then recommends solutions that can help you improve the cost effectiveness, performance, high availability, and security of your Azure resources. The Advisor cost recommendation page will help you optimize and reduce your overall Azure spend by identifying idle and underutilized resources. For example, you may think about the virtual machines that have been sitting in the Azure subscription for a long period of time. How many virtual machines have CPU less than 10%? How many hard disks that are attached to the machine have IOPS less than 10% being used? Are we overcommitting to the resources? So you can select the recommended action for a recommendation to implement the recommendation. A simple interface will open that enables you to implement the recommendation or refer you to the documentation that assists you with the implementation. Azure Advisor provides recommendations for virtual machines, availability sets, application gateways, app servers, SQL services, and Redis cache. So here I am in the Azure portal walking you through the Azure Advisor service offering. So as you see, we got 5 major categories: high availability, security, performance, operational excellence, and cost. So here Azure Advisor is giving us recommendations about each one of these categories. If you click on each one of them one by one, you'll start to see those recommendations. Under high availability, as it says, we need to enable active gateways for redundancy. The potential benefits of activating it, what are the impacted resources, and when was it updated. Now if you click on this description further, it will tell you the documentation and also the affected resources. You can click on this Learn More button to know more about the benefits of activating it. This pane here acts like an alerting tool as well, more like a ticketing tool. So I can check this box and either choose to postpone it so that it does not appear on the screen for some time, or dismiss it totally so you will never be able to see it on the screen forever. You can download it as a PDF so you can then send it to a particular department or create an alert. We'll talk more about alerts in a minute. I'll go back to high availability section, look at the second recommendation. It says use availability sets for improved fault tolerance, and similarly for others. You can go back and then look at other recommendations here under security. It says that I gotta enable multi-factor authentication with owner permissions on your subscription. If you click on it, it will take us to the documentation as to how do you enable multi-factor authentication for certain accounts. There you go. You can click on Learn More, which will take us to the documentation and the affected resources on the bottom. There are remediation steps, and it tells us how do you enable multi-factor authentication. Here is a step-by-step manual. You can follow this to enable MFA for your users. What will happen if MFA is not enabled? Well, these are the threats. An account can be breached or a privilege elevation can happen. Let's look at performance category. At this point, we do not have any performance recommendations, but usually you will see if a CPU is being overutilized or underutilized, you will see them under performance section. So Azure Advisor now has a new category called as operational excellence. This wasn't there till the last Ignite program in November. So this new category will help us follow best practices for efficiency, workflow processes, resource manageability, and deployment. Azure Advisor's new category will help us follow better processes. As you see, some of these recommendations are listed right here. For example, enforce audit VMs that do not use managed disks using Azure policy. Now, if I click on it, it will tell us the affected resource and then also tell us how we can enable it. What are the possible recommendations in this case? As always, you can postpone and dismiss this action if required. Under cost, you will see methods to optimize and reduce your overall Azure spend. This is done by identifying your idle and underutilized resources. So you can now get cost recommendations from this cost tab on the Azure Advisor dashboard. Although certain application scenarios can result in low utilization by design, but you can often save money by managing the size and number of virtual machines. Azure Advisor's evaluation models will consider a virtual machine for shutdown when the max value of CPU utilization is less than 3% and network utilization is less than 2% over a 7-day period. You can see all recommendations. This is a one-stop shop for all the recommendations in one single place. So you can consider Azure Advisor as your personalized cloud consultant that will help you follow best practices to optimize your Azure deployments. It will analyze your resource configuration, usage telemetry, and then recommends solutions that can help you improve the cost effectiveness, performance, high availability, and security of your Azure resources. Azure Activity Log is a subscription log that provides insight into subscription level events that have occurred in Azure. This includes a range of data from Azure Resource Manager, operational data to updates on service health events. With the activity log, you can determine what, who, and when of any operations that have taken place in your subscription. You can understand the status of the operation and other relevant properties. Through activity logs, you can determine what operations were taken on the resource in your subscription, who started the operation, when the operation occurred, the status of the operation, the values of different properties that might help you research the operation. These activity logs are kept for 90 days. You can query for any range of dates as long as the starting date isn't more than 90 days in the past. You can retrieve events from activity log using Azure Portal, CLI, PowerShell commandlets, and also with REST APIs. At this time, I'm logged into the Azure portal, connected to my subscription, and then search for activity log in the search box. As you see, I can see all my operations that have happened in the past and that probably are currently occurring. So if there are any activities that you or your team members have done in the past, it's all going to be visible here. Like I was saying earlier, what operations were taken place on this particular resource in your subscription is visible here. For example, the first line says there was an Azure automation job created. Who started the operation is visible in the last section, which is event initiated by. When the operation occurred is the timestamp. The status of the operation is whether it's running or not, accepted, started, or failed is visible here. Which subscription is the activity happening on is also visible there. So you can see all the events that are happening in your subscription. You can also query the activity log. In the Azure portal, you can filter your activity log by these fields which are there on the top. You can also add multiple filters here by adding resource, resource type, operation, event initiated by, or event category. You can also search for a specific object. So if you want to search in a particular resource group to identify what's going on there, you can click on it and find it. The various filters available in activity log are available right on the top. For example, the subscription option will let you select the subscriptions that you have in your enterprise. Time span is the start and end time of the events. Event severity is the severity level of the event. It could be informational, warning, critical, or error. The resource group is one or more resource group within your subscriptions. You can also add more filters by clicking on the filter button and then selecting the kind of resource you want. So you have the resource type, which is the type of resource, for example, virtual machines, or the operation is the name of the Azure Resource Manager operation, for example, SQL read-write operations. The next option, event initiated by, will tell us the caller or the user who performed the operation. Event category will be explained in the next video, which will then talk about administrative, security, service health, etc. I'll describe them in the next video. So once you have defined a set of filters, you can pin the filtered state to the dashboard or download it using the CSV option available right there. Let's take a look at what we have under the event category section. Now, under event category, I've got the following options like administrative, then there is service health, security, alert, recommendation, policy, auto scale, and resource health. Let's take a look at each one of them one by one. Administrative. This category contains the record of all create, update, delete, and action operations performed through the resource manager. Example of these types of events you would observe in this category, which will include creating a virtual machine or deleting a network security group. The administrative category also includes any changes to role-based access control in a subscription. The next event category is security. This category contains the record of any alerts generated by the Azure Security Center. An example of this type of event would be when you observe a category like suspicious double extension file executed, or malware detected, or probably hard disk not encrypted. The next category is service health. This category contains the record of any service health incidents that have occurred in Azure. An example would be if the SQL Azure in East US is experiencing downtime. Service health events come in 5 varieties: action required, assisted recovery, incident, maintenance, information, or security. The next kind of category is alert. This category contains the record of all activations of Azure alerts. An example of this type of event would be if you observe CPU on your VM, which has been over 80% for past 5 minutes. These are the kind of alerts you will see. The next category is recommendation. You would see recommendations on your resources like Azure websites and SQL. These events offer recommendations for how to better utilize your resources. The next one, policy and resource health combined. These are reserved for future use. These categories do not contain any events. The last one is auto scale, and this category contains the record of any events related to the operation of auto scale engine based on the auto scale settings you might have defined in your subscription. So if scale up has happened or scale down has happened, then you will see such actions here. An example of this type of event would be if you observe this category in auto scale up action failed. So if auto scaling up or down has failed or has succeeded, you will see such option in this category. Let's take a look at Azure alerts in the next video. In Azure Monitor, you have a section called as alerts. Alerts proactively notify you when important conditions are found in your monitoring data. They allow you to identify and address issues before the users of the system notice them. Alert consists of alert rules, action groups, and monitoring conditions, which we'll take a look in a minute. Let's go ahead and create a new alert. I'll click on this new alert rule button to create a new rule. You will see the following options like resource, condition, actions, alert details, and description. Let's go through them one by one. The resource. With resource, you will select the resource you want to monitor. For example, resource group or a virtual machine or a storage account. So once you click on the select option, you'll then have the options to filter your resource and select an appropriate resource that you want to monitor. I can expand them, and then you'll be able to see all the resources available under that. You can also filter them based on the resource type, their location, or you can choose custom filters. I'll click on done here. So right now my resource is my entire subscription. The next option is a condition. This is where you select the signal and define its logic. The signal could be all, or specify a metric, or specify a particular activity log. As I scroll down to the bottom, I will see more and more signals here. You can select, let's say, regenerate keys or delete accounts. So if I click on this particular item, I will see a condition that is deleting accounts. So whenever accounts are deleted, I will then get notified. I'll click on done here. That means I've selected a condition which is monitoring the deletion of accounts in my subscription. Scroll down further, it then tells me actions that you want to take. Do you want to get notified, or your team wants to get notified through email or text messages, or you want to automate actions using webhooks or runbooks or functions or logic apps? And this is done by an action group. An action group is a collection of notification preferences which is defined by the owner of the subscription. So if I click on create action group, it will ask us, how do you want to get notified? Azure Monitor and Service Health will use action groups to notify users that an alert has been triggered. Various alerts may use the same action group or different action groups depending on the user's requirements. So when an action is configured to notify a person by email or SMS, the person will receive a confirmation indicating that he has been added to the action group. So right now, if I click on action type, you will see the various action types that we have as on today. I was referring to email, SMS, or even automation runbook, but there are more options available right here. So if I select email, the notification will be sent to an email address. Ensure that you have email address configured appropriately, and you can have up to 1,000 email actions in an action group. ITSM. You can have up to 10 ITSM actions in an action group ITSM action, and this will of course require an ITSM connection. What is a logic app? You can have logics defined that if a particular action or a rule gets triggered, then do this. So you can have up to 10 logic app actions in that action group. Similarly, you can have a function defined, runbook, SMS, voice, or a webhook defined. Here in webhook, you can specify up to 10 webhooks, and the timeout period is 10 seconds. The webhook call will be retried a maximum of 2 times when the HTTP status codes returned are either 504, 503, 408, or 429. So that's what action type is. Cumulatively, this is called as an action group. Now I'll just close it without defining anything. Then moving forward, you have alert details. Under alert details, you will see a rule name. You can just specify a rule name to identify your alert, a description just to provide certain description to your alert rule, and then whether you want to enable rule creation or not. It takes up to 5 minutes for the alert to become active. Alerts are used by most of the organizations because alerts will help us notify proactively when certain conditions are met. It is important that you as an Azure administrator configure the appropriate rules and set the timings appropriately. You don't want to get bombarded with too many alerts at the same time, so make sure that you configure the right number of alerts for the right parameters. One of the challenges with many broad data analytics solutions is figuring out where you can provide value for your organization. Out of all the things that are possible, what does your business need? What we hear from customers is that there are several areas and all have the potential to deliver significant business value. Let's talk about these examples. The first one is about assessing updates. An important part of daily routine for any IT administrator is assessing system update requirements and planning patches. Accurate scheduling is critical as it directly relates to SLA to the business and can seriously impact business functions. In the past, you had to schedule an update with only limited knowledge of how long the patches would take. Operations Management Suite collects data from all customers performing patches and uses that data to provide an average patching time for specific missing updates. The second example is change tracking. Troubleshooting an operational incident is a complex process. This requires access to multiple data streams. With Operations Management Suite, you can easily perform analysis for multiple angles using data from a wide variety of sources through a single interface for correlation of information. By tracking changes throughout the environment, log analytics helps to easily identify things like abnormal behavior from a specific account, users installing unapproved software, unexpected system reboots or shutdowns. It will even show you the evidence of security breaches or specific problems in loosely coupled applications. In the next video, let's see how you can use log analytics and the workspaces involved in it to connect to different sources of information like Windows, Linux, or Azure storage. So here again, I'm in the Azure portal. Let's go click on the search box and type log analytics. So there we go, it pops up. I click on it. It takes us to the regular screen where you have Log Analytics workspaces. We have to create a workspace under Log Analytics. So that means that to get started with Log Analytics, you need to add an Azure workspace. We have the blade for Log Analytics. You have two options, whether you want to create a new Log Analytics workspace or link existing. We do not have any workspace at this point, so let's click on Create New. And then you can just type a name. So we'll provide a name for the new Log Analytics workspace. I'll just call it as Log, my caps is on, Log Analytics Space, okay? Now, make sure that you follow your naming standards and conventions. We got a message there. Let's see what it is. The workspace name is already used. Please try another one. What does that mean? It means that it must be globally unique, right? So take that off. Let's give it some creative name. It gave it a name like log space 321 and it accepted. Subscription is pay as you go in my case. Select a resource group. I'll prefer to create a new resource group specifically for this guy. Say lab and say okay. And which region do you want to host this? Pricing tier is also very important to understand. How much would you pay to store the logs from different sources into Log Analytics? Let's say you've got 100 Windows servers and you're gathering all kinds of logs like application, security, performance, setup, and all logs from your on-premise infrastructure as well as from Azure into Log Analytics workspace. Then we are talking about a lot of storage that it will be consuming. So we need to understand how much would you pay. Microsoft has a pricing tool here, so you can go and look at the Log Analytics pricing. And here you go. For 100 GB per day, you're being charged like $219 per day. For 200, it's $412. 300 is $604. So you may have to look at cost benefit analysis of using Log Analytics. The prices are right here. And to get onto this page, I just clicked on this URL here, which says Log Analytics pricing. Okay. For this demonstration, I'll click on OK and we'll see what the bill will be. And click on OK and give it some time for it to create the workspace. There we go. Our Log Analytics workspace is created. I'll click on it to see what options we have. Well, we've got numerous options, but first thing that we do is to start collecting data from our sources. Remember that Log Analytics is a place that will help us analyze the logs, just like the name it says. But where does it get the logs from? From the sources. And the sources could be your virtual machines, your storage, or it can be databases. Now to get those logs, we need to install an agent on the devices. It could be a virtual machine or physical machine or whatever kind of device it is. Where do we get the agent from now? And then click on Quick Start. And then it says choose a data source to connect to the workspace. Now if I have any Azure virtual machines, then they will be displayed right here. At this point, I do not have any virtual machines, but let's see how you can install it on, let's say, AWS infrastructure or Google Cloud infrastructure or on-premise. Let's say you've got about 250 virtual machines and 30 physical machines sitting on your premise, and you want to install this Log Analytics workspace agent there on those machines. How do you do that? Well, you can just click on this computer section and download the relevant agent for Windows. It could be 32-bit or 64-bit. Depending on the agent you have, you may want to download this. What's interesting is that you also have an agent for Linux. You can use the wget command and then use these binaries in this GitHub location to download those binaries. During the installation of the log analytics agent, it will ask you, where should I connect to? What is your workspace? What is the primary key? Well, these are the variables that you need to input to the wizard for it to have successful connection to log analytics. In this case, I'll just go ahead and download a 64-bit version on my Windows laptop. Let's see if it can gather information from my Windows-based machine, which is a Windows 10 box. It will take some time to download it, and I'll pause it for a minute and then resume it once it is downloaded. Okay, looks like it is downloaded. Let's begin the installation of the agent. Now, this will be installed on a non-server based Windows system. This is a simple Windows-based client, a Windows 10 machine. It's just like a regular installer, just next, next, next. And one thing to notice is that it will ask for the workspace ID and the primary key. Do you want to connect to Azure Log Analytics or SCOM? SCOM is a monitoring tool from Microsoft, and this is usually used on-premise. And this is usually used for on-premise based solutions. But because our solution is in the cloud, I'll select connect the agent to Azure Log Analytics and move on next. Now this is where I need to type in the workspace ID. Of course, I'll not type this in, just copy this, go back and paste it. Do the same thing with the primary key and paste it there. The kind of Azure cloud we're using is Azure commercial. It's not US government, it's not US China, it's a commercial one. If you have any proxy set up, then you may want to select a proxy. I'm connected directly to the internet without any proxy, so I'll just leave it there and click next. Like that. Just wait for the installation to do its job. Finally, do you want to have Microsoft updates? Well, I'll just select not to have it at this time and then let it install. Looks like the installation is complete. I'll just click on finish. So now that the installation is complete, let's go ahead and see if we can query certain logs from this machine and look at certain performance logs or identify what log analytics can find. I'll scroll down to the bottom here a little bit, and then you will see something called as logs. If you click on logs, you will see a screen that looks like query analyzer, something in SQL. So if you have worked on SQL, you'll see a similar box where you can type SQL queries. Now here I've got some preloaded queries, which is computer availability, and then you got certain metrics out there. You can also identify the performance of my machine and see what data is being collected, and then the data usage as well. I'm more interested to know the performance of my machine, so I will find out how much memory and CPU has been used in last hour. Let's click on run. Looks like it doesn't have all the data. So how do we configure this machine to get certain data and not get certain data? Because in production environments, you may not need all the data. And keep in mind that in cloud, you are paying per GB. So let's go and find out how you can configure the metrics that you want to calculate. To configure the kind of data that you want to gather in log analytics, you need to click on the advanced settings. Here you will see the number of virtual machines that are connected. For example, here you see that I have one Windows computer connected. Then under the data section, you can configure the data that you want to collect from the machine. So do you want to collect Windows events or performance counters, or if it's a Linux machine, if you would like to gather certain Linux performance counters or IS logs. You got the logs on the screen and you just have to select what kind of events you want to pick up from your machine. Furthermore, you can click on this and start typing, let's say, performance. It will automatically populate the performance counters. So let's say audio related performance or device UX related performance or health related information of that machine. So there are a lot of options right here. Let's type security. Again, we got performance counters as far as security is concerned. So you can pick and choose the kind of data that you want to select and then click on add. Now from that machine, which has the agent installed, you will just get the security logs and you'll not get performance related issues or setup related or installation related logs onto Azure. So you are filtering what you need from the machine and then transporting those logs from that individual device to Azure. That way You can guarantee that you have what you need and your bills will also not rise. I'll add few more counters here. Let's type performance because that's one of the favorite things that admins look forward for. Let's see NTFS performance. How is your disk doing? How about application? Anything specific related to application? Now this is not a Windows server. It's just a simple Windows 10 desktop, so I will not have any server related application issues, but I may want to gather the entire application log. And let's click on add. Now that should be good enough for the demonstration. And then I'll click on save, click on OK, and then refresh it to make sure that it's there. Go to the data, and then yeah, it's there. Close it, and then go back to my logs so that I can see the querying section. Now this log analytics provides the query syntax to quickly retrieve and consolidate data in the repository. You can create and save logs as well. So once you have the log written in this search box, you can save it for future queries. Let's see if we can run a few more sample queries. I'll click on the sample query and then click on computer availability to see if it is actually sending logs. Now I've got certain graphs here. The data is displayed in two formats. One is a table and second is a chart. If you look at the table, it tells me that there's one device that is sending the information to log analytics. And that's exactly right because we got the agent installed on one device. You can also get it in a chart format. Let's run some more sample queries. Computer availability, scroll down, list all computer heartbeats from the last 1 hour. That's so interesting. Click on run and see what we get. There you go. We got so many heartbeat signals in last 1 hour. Although it's not been more than 20 minutes that we have installed the agent, but we got quite a lot of information from that machine. Yes, my desktop name is this. My IP address may be this. I'm not sure, but looks like the public IP that I have is as follows. But you can expand this and gather some more information there. Yes, it's a Windows machine, Windows 10. But how about looking at it in the form of a chart? Yeah, I'll click on the chart and see how the graphs automatically are created. So log analytics gives you a quick graphical view of the health of your environment. You can also add your own visualizations by clicking on these buttons. How do you want to see the graph? Like this, or probably in the form of a pie chart. And then eventually you can save these logs and save the data that you have gathered by just clicking on the save button. When you build a query like this here, you start by determining which tables of data that you want to query. On the left hand side, the schema of the logs is created. If you expand this, you will see the entire schema. What you're doing essentially is collecting the data from these tables. So when you build a query, you start by determining which tables of data that you want to query and what you're looking for. Each data source and solution stores its data in dedicated tables in Log Analytics workspace. And these are the dedicated tables I'm referring to. Let me pick up another query and show you maybe a complex query. Go to computer availability, computer performance maybe, and then look at this. Perf pipe summarized by object and count name. Now this is the basic structure of the query. It is usually followed by a series of operators separated by a pipe. For example, summarize by is an operator. So you can chain together multiple operators to refine the data and perform advanced functions. More pipes you have, more filtering and refinement you're doing. Log Analytics also has alerting inbuilt. So if there is certain statistics that you want to query for and also want to get alert, let's say if the CPU goes about 90% for a particular virtual machine and you want to get alerted, then you can have the alert rule set right here. You can also copy this information to the clipboard and save it, which we just spoke about. Most interesting thing is what you'll see is on the settings. Display the time zone. At times your virtual machines may be East US. There's no point looking at the times in UTC, so then you have to change it back to Eastern Standard Time. Do you want to sort the results? On or off? Table view, how many do you want to see per page? Smart diagnostics analysis. This is more of giving you certain patterns and correlating the information. Log Analytics query history is saved for 30 days. This is very important to know From the compliance and governance perspective, people may ask you, how many days is the log analytics data storing for? Now you know the answer. 30 days is the answer. And after that, the information is cleaned up based on first in, first out basis. So what is log analytics? Log analytics is gathering the logs and also giving us statistics, helping us troubleshoot, gather the information, helping us identify any kind of abnormal behavior from a specific account, because logs from all the machines are just stored here and I can use the queries to get that information. Are users installing unapproved software? Are there any unexpected system reboots or shutdowns? Is there a security breach in last 30 days? Or any loose coupled applications having issues? Everything can be identified with log analytics. With proper querying and proper filtering, log analytics becomes a very powerful tool. Azure Network Watcher provides tools to monitor, diagnose, view metrics, and enable or disable logs for resources in Azure Virtual Network. You can automate remote network monitoring with packet capture. With this feature, you can monitor and diagnose networking issues without logging into your virtual machines. You can trigger packet capture by setting alerts and gain access to real-time performance information at a packet level. When you observe an issue, you can investigate in detail for better diagnosis. You can gain insight into your network traffic using flow logs. You will then build a deeper understanding of your network traffic patterns using network security group flow logs. Information provided by flow logs helps you gather data for compliance, auditing, and monitoring your network security profile. You can also diagnose VPN connectivity issues. Network Watcher provides you the ability to diagnose your most common VPN gateway and connection issues. This allows you not only to identify the issue, but also to use detailed logs created to help further investigate. Let's take a look at the features we have in Network Watcher. So I'll click on Network Watcher. And then, as we understood earlier, that Network Watcher has several tools that will help us monitor, diagnose, and look at the metrics, and also enable or disable logs in the Azure Virtual Network. So under the monitoring section, what we have is something called as Connection Monitor. This Connection Monitor is a feature of Network Watcher that can monitor communications between virtual machines and an endpoint. That endpoint could be a resource in Azure or could be a public endpoint. The Connection Monitor will monitor the communication at regular intervals and informs you about its reachability. It will also tell us about the latency and network topology changes between the virtual machine and the endpoint. For example, you may have a web server. Now in this case, I have already created a server called as prod server, and it's there under the virtual machine section. So if I go there must be two. Okay, I've got two servers. One is a prod server and a dev server. I'll go to connection monitoring, and then you can enumerate the virtual machines that we have in that region. So I'll select prod server. Then you can select a destination server as well. Let's select dev server here. Now we have the option to choose a port number. Let's assume that prod server is a web server that communicates with a database server called as dev server. Someone in your organization may, probably unknown to you, apply a custom route or a network security rule to the web server or the database, or probably the entire subnet. So if this endpoint, which is a database, becomes unreachable on that port, this connection monitor will inform you or notify you on this dashboard. You may see potential reasons. That could be a DNS name resolution issue, the CPU, memory, or firewall within the operating system of the VM, or the hop type of the custom route, or maybe security rule of the virtual machine preventing the communication to happen. Connection Monitor also provides the minimum, average, and maximum latency observed over time. In this case, I'll just type port number 1433, that's the database port, and just creating a scenario where prod server is communicating with the dev server, the database server, on 1433 port number. You have to just give a name here, database communication or something, and then finally click on add. It will take a minute to add it to the connection monitor, and then we'll be able to see the traffic between prod server and dev server on port number 1433. So connection monitor in the network watcher section helps us monitor the communication between two endpoints. In this case, we have two virtual machines. One is a prod server, another is a dev server monitoring on 1433, and we'll get constant data triggers between these two devices. At this point, there is no data available because we just created it. Once the polling interval starts, we'll see the data flowing into the connection monitor. Under Network Watcher, there is a service called as Topology. Network Watcher's topology enables you to generate a visual diagram of the resources in a virtual network. It also shows the relationship between the resources. The picture here that the topology generated shows an example topology for a virtual network that has multiple subnets. In this case, I have a VNet and a subnet. In that subnet called as default, I have two virtual machines loaded up. One is a dev, and another is a prod. So by looking at the picture, we can figure out that each of those network cards are associated with a network security group. They also have an IP address allocated to the network card. It shows the relationship between resources and how they are connected. To use Network Watcher capabilities, the account you log into Azure with must be assigned to the owner, contributor, or network contributor built-in roles. So the topology under the Network Watcher helps you generate a visual diagram of all the resources you have in that resource group. You can filter the resource group by clicking on the resource group section here and then identifying the network for which you want to generate the topology. We are here under the network diagnostic sections of the Network Watcher. We're talking about IP Flow Verify. The purpose of IP Flow Verify is to quickly diagnose connectivity issues from or to the internet and from or to the on-premise environment. For example, confirming if a security rule is blocking ingress or egress traffic to or from a virtual machine. Let's talk about an example. When you deploy a virtual machine, Azure applies several default security rules to the VM that may be allowing or denying traffic to or from the VM. You might override Azure's default rule or create additional rules. At some point, a virtual machine may have inability to communicate with other resources because of too many security rules. The IP Flow Verifier's capability enables you to specify the source and then the destination's IP address, which is the remote IP address, along with their port and protocol, TCP or UDP, and then the traffic direction, whether it's inbound or outbound. And then IP Flow Verify can test the communication and inform you if the connection succeeds or fails. If the connection fails, the IP Flow Verify tells you which security rule allowed or denied the communication so that you can resolve the problem quickly. IP Flow Verify is ideal for making sure security rules are being applied correctly. When used for troubleshooting, if IP Flow Verify does not show a problem, you will need to explore other areas such as firewall restrictions. So this is one of the logical methods of troubleshooting. The purpose of next hop is to determine if the traffic is being directed to the intended destination by showing the next hop. This will help determine if the network routing is correctly configured. When you create a virtual network, Azure creates several default outbound routes for the network traffic. The outbound traffic from all resources, such as virtual machines, are deployed in a virtual network, are routed based on Azure's default routes. You might override Azure's default routes or create additional routes. For example, you may find that a virtual machine can no longer communicate with other resources because of a specific route. The next hop capability enables you to specify a source and destination IPv4 address. The next hop then sets the communication and informs you what type of next hop is used to route the traffic. You can then remove, change, or add a route to resolve a routing problem. The next hop also returns the routing table associated with the next hop. If the route is defined as a user-defined route, then the route is returned. Otherwise, next hop returns system route. Depending on your situation, the next hop could be internet. It could also be a virtual appliance or a virtual network gateway or a VNet peering. If you see here, there is a virtual machine that I've set up already.
And the name of the virtual machine is dev server. So I select the dev server here, and then automatically its network interface is populated. If you got multiple network interfaces attached to the virtual machine, you will see them here. You may want to select the appropriate one. Its private IP address is automatically picked up. What we have to type is a destination IP address. Now it could be a private IP or a source on the internet. The destination IP address fields accepts an IP address only and not a name. It must be in the form of IPv4. Let's say if we want to check the route from 10.0.0.5 to an endpoint on the internet like google.com, then we have to type Google's IP address. To make things simpler, I've already done an NS lookup for google.com, and I have an IP address which is 172.217.22.35. I'll copy it and paste it right here on the destination IP address field, and then click next hop. In this case, I see the next hop type as internet, which is right. So the next hop is testing the communication between the source IP 10.0.0.5 and the internet. In this case, I've got next hop as internet. If it was intranet, that means the resource within Azure, you would have got probably virtual appliance, network gateway, VNet local, VNet peering, or sometimes none as well. If you get none here in this next hop type field, it lets us know that while there may be a valid system route to the destination, there is no next hop to route the traffic to the destination. And that's a triggering point to troubleshoot the network issue. The next feature that we're going to talk about is Azure Network Watcher Connection Troubleshoot. This is a very recent addition to the Network Watcher suite of networking tools and capabilities. Connection Troubleshoot enables you to troubleshoot network performance and connectivity issues in Azure. This adds to the current capabilities of Network Watcher in providing even more ways of you to troubleshoot network operations. You can do various things here with this troubleshooting tool. You can check the connectivity between the source virtual machine and destination virtual machine, or it could be an FQDN or an IP address. You can identify any configuration issues that are impacting reachability. This little tool here also provides all possible hop-by-hop paths from source to destination. Let's take a look at an example here. Now I'm in the Network Watcher section of Azure, and once you click on Connection Troubleshoot, you'll land up in a screen where you got to fill up these fields like the source server and the destination. Now in this case, my source is the dev server and the destination is a prod server. They are already created and ready for testing in my tenant. Now the port number that I want to test is 3389. This is an RDP port, Remote Desktop Protocol, and this is enabled by default in Windows 2016. I want to check if this is reachable from the source server, which is dev, to the destination and prod. I'll click on check to see what happens. The next thing is it should tell me various parameters like latency, minimum, max, and average latency between source and destination. When needed, it should also tell the number of packets dropped between the connection troubleshoot check. So looks like the result is ready. The status is reachable. The source is dev server. Here are their private IP addresses. The next hop from dev server is going to 10.0.0.4. The average latency is 1 milliseconds. Minimum is 1, maximum is 2. Total probes sent were 66. And no packets were dropped. There are no probes that failed. Best part is that if you click on the topology view, it also gives you a graphical view from source to destination. So Azure Network Watcher Connection Troubleshoot is an excellent addition to the Network Watcher suite of networking tools. So here's the graphical view of the connection between the dev server and the prod. So if your network infrastructure is too big, and if it has multiple connectivity routes, then you will see a larger picture. So you can scroll left or right to see the diagram. The connection troubleshoot option in the Network Watcher section has proved to be a very interesting and helpful tool to troubleshoot your network operations.